titles, like the order that, I know it's like numerically, except I think ideal gas law, I put 46 and it should have been 43. If I have time, I'll show you the list. Why are we throwing things across the room? So you should be able to, if you have, y'all, if you have been taking your notes on paper, you need to start digitally moving them over. Yeah, notes and assignment. We do still have to do a solubility curve. Depending on how long the review is for your CBA, I might be doing the review Tuesday and the solubility. No, that's not going to work because you have to have a solubility curve first. You guys take your CBA on Thursday, right? You guys are even? Isn't it odd than even?
I think so.
Yeah, that I'm not here. So that gives me a 30-minute period Wednesday. Okay, so if the review's short enough, then we'll do the solubility curve Tuesday and the review for the CBA on Wednesday. I don't know. I haven't gotten that far. So at least you guys have a little bit of extra time. Remember, your notebooks are a test grade. There needs to be a digital submission. For the opener, we talked about some of these words yesterday, y'all. Shh, boys. I've got 3 words up here. I've got solution, solvent, and solute. Do you know what one of those 3 words actually means? Because we talked about the solvent is which one? Is it the liquid or the solid part? Okay, there you go. All right. So now that is a blanket statement. So the solvent, okay, is normally a liquid. It doesn't have to be, but that's the thing that does the dissolving, the solvent with a B. Whereas the solute is the thing that is dissolved. Now, it doesn't have to be a solid. It could be a gas or another liquid, but it's the thing that is dissolved. And so then what the heck is a solution? Gosh, what is a solution then? Using those 2 words, what is a solution? The result of the solvent dissolving the solute. A good example of this is if you make like Kool-Aid or sweet tea or something. Okay, your liquid is the tea. Okay, what is the thing that you're trying to dissolve into the Kool-Aid or the tea so it doesn't taste horrible? Sugar. Okay, so the sugar would be the solute, the water portion of the tea or the Kool-Aid. I mean, it's not the coloring and the flavoring that does it, it's the water. That would be your solvent. The solution would be whatever it was that you just made. All right. This is the last one in this 6 weeks. The only thing that we have left to do, there's only 2 things for you to fill on this slide. The only thing we have left to do is to do what is called a solubility curve, which really should go in with this, but the notes are too long to do that too. So now I say this probably different than you were taught. I was taught to pronounce it homogeneous. If you say homogeneous, I don't care. It's okay. It's not the way I was taught. A homogeneous mixture happens when you have the solid particle, the solute, that dissolves into almost always the liquid thing, which is the solvent. The solute is the thing being dissolved. No, it does not have to be a solid. It could be a solid, liquid, or gas. The solvent is the thing that does the dissolving. It doesn't have to be a liquid, but for us, it's normally water. For salt water, like ocean water, sea water, which has a lot of stuff in it, you got the regular water, which is the solvent. The sea water or ocean water would be the solution. And then the solute would be the salt, amongst other things that goes into seawater. But that's basically the solution is the concoction. The thing that was dissolved is the solute, and the thing that did the dissolving is the solvent. I wish I had a stupid way to keep the 3 straight, but I don't. If I could tell you. Solubility is how much of
I didn't get the first part.
Salt and water. Salt and water. I try to put the stuff that needs. Most of your notes are already done. I'm still like money.
You're really good. Salt and water.
Just salt and then water. All right. So solubility is basically how much of the thing that's dissolving will go into the liquid. We can bring in gas laws for this, but we're not going to. This section is all conceptual, just means vocab. Then unit for solubility is normally per 100 grams of solvent. So how many grams of the thing that's dissolved per 100 grams of the thing that is the dissolving? And then, excuse me, the way that you switch this from grams, from solid to liquid, is you just replace it with a milliliter. Not that you have to do that on today's stuff. But for solutions, if the substance will dissolve, it's soluble, like putting sugar in water. It should dissolve. Okay, that means that it is soluble. If it is insoluble, then it won't dissolve. So if I take chalk, like the stuff over there, grind it up, I've got a mortar and pestle, even though it's ionic, if I throw it in water, it's not going to dissolve, and so that's considered to be insoluble. The prefix in means against or not. If you've never been taught that, that's what in means, at least as a prefix, not like you're in something. All right, anyways, so there are some solutions that are made up of liquids. The solute is a liquid and the solvent is a liquid. So they don't use soluble and insoluble. If it will dissolve, it's called miscible. It'll mix and not separate. That's what miscible means. So if it's not going to go into, it should be not in, but immiscible. I'm sorry, oh, there was one more. Didn't mean to, you know what? Let me check appendix while I'm thinking about it. I said yes, I know these notes are long, but most of them are already done. Let me just check them real quick and we'll move on. Oh, it's just late. Okay, so there's also solid with solid, but we don't go that far into this. That's how you make alloys, like different types of rims on cars. They look like they're really shiny, but they're stronger, don't scratch, more durable. It sure is. All right. Un means not, like not even a little. If it is unsaturated, then you're going to be able to let the solid dissolve into the liquid. Like it'll work, it'll go. If it's saturated, that means it's filled to capacity with that solute, but there's not too much. It's like perfect amounts. And if you take what they call a seed, which is like a grain of salt or a grain of sugar, whatever, and you pop it into a saturated container, it'll sink to the bottom. Super saturated is different, and there's things that we can do to solutions to have more of the solid in the liquid than we would normally have. And if you take that same grain of salt and you put it in something that's super saturated, if you watch the liquid, a bunch of salt particles are going to start falling out of solution. So this is something that we would have done back there, but we're running out of time, especially since I have to not be here Monday. So that single grain of salt or sugar is called a seed crystal. If you've ever grown crystals before, they give you seed rocks. My kid loves that kind of stuff. I know y'all are sort of out of that age thing, but you can grow crystals. If I went too far, if you drop a single grain of whatever, let's just use sugar and water, a single grain of sugar into something that's unsaturated, it's going to disappear. It's going to dissolve. It's still there, but it's in the solution. Sugar water. If you have a perfectly 100% saturated sugar water solution, I take that, well, I guess a different one now, different sugar grain and drop it, it's just going to fall to the bottom. It's not going to make extras come out. It's just sort of passing through. It can't go into the solution. It's full. Okay, now if you have a super saturated solution that has more sugar in it, which there's ways that we can do this. We'll get to that in a second. You take a grain of sugar, put it in, it's literally going to start raining sugar crystals out of the solution and they'll settle on the bottom. I know you have to know this in some way, shape, or form with your CBA. I just don't know how they ask it. They have a lot of math on your CBA. From what they were talking about, the people who do get to see it, doesn't sound very friendly. But I don't know. So hopefully the review that they make will be adequate for you. All right, how do we make the solid dissolve faster? Heat it up. Number one is you heat it up. Okay, the other thing you can do is stir it. Okay, so agitation. If you stir faster, you're gonna have more of it go into solution. The next thing you can do is increase the surface areas. Okay, y'all have seen sugar cubes before, right? Like you feed horses and put in tea, like the cubes that are like that big.
What sugar? I don't know
What sugar? Y'all know what I'm talking about, a sugar cube, right? It's like that big cube. You really never, okay, so if you take a sugar cube and you put it in just regular clean water, okay, it's gonna dissolve. But what could you do to the sugar cube to make it dissolve faster? No, crush it up first. If you crush up the cube into the individual grains, you have more surface area and it will dissolve faster. Now, if you really wanted it to go quick, then you'd do a combination of all of them. You could, but I would, microwaving all of your food is really bad for it. So, it says sweet tea, Kool-Aid will work, anything that you put sugar in. When you have, somebody said heat it up, okay? When you have a liquid, how many of you have ever had sun tea before? Okay, where you get the big container and you stick it out in the sun. Doesn't that taste better than regular old tea? Okay, do you know why?
That's fine.
It's the sun. It's naturally heated, okay? Most people don't put anything extra into their sun tea to agitate it, but sometimes you do put lemons and crap in there too. But yeah, it's the natural process. And it gets a lot stronger too, depending on how many tea bags you put in there. So your solubility will increase with the increase in temperature. With a gas and a liquid, in general, I had to blow my nose, y'all. This pollen is crazy. Give me a second. It's not going to help, but I have to because it's itching. Okay, for a gas, now, okay, so that was for a solid. For a gas, it does the opposite. If you heat it up, it actually sort of bubbles the gas back out of the solution. I can't remember if there's another one on here or not. I have to cheat. Yeah, there's one more. Okay, and then we also have Henry's law, which I don't think you guys have to learn any mathematics for this at all. I think we're sort of done with our math section for this 6 weeks. Your pressure and your solubility are directly proportional. That means if the pressure goes up, the solubility goes up. And the other type is an inverse, where if one goes up, the other goes down. But Henry's law is directly proportional. No, we're not going to learn a formula. If there is one, I've never learned it myself. All right, is this the one where we fill out? No, somewhere there's a huge chart. Oh, this is the big space that you guys have to fill. What affects the amount of a substance that will dissolve into a solution? We normally do talk about dissolving a solid into a liquid. The temperature of the liquid, the solvent, how much of the solid and the liquid are there to begin with. Okay, so is it saturated or supersaturated or what? Whether it was agitated or not. How big the particles were. Like I said, the difference between a sugar cube and a grain of sugar, which looks the same shape as a sugar cube, it's just smaller. And then what it's made out of in particular. Suspensions. We got to go through suspensions and colloids. Wow, there was a lot on this one. I really wish they would have broken this up into two. And the last one, because we're running out of time. Anyways, a suspension has large particles that will settle over time. So like if you go and get a mason jar and you scoop up a bunch of crap in the pond and you screw on the lid, shake it up, eventually all the dirt and stuff is going to sink. And you might have this disgusting layer of water and then maybe some algae on the top. That is a suspension. The regular old like tea, no ice cubes. Screw it on and then shake it up, blah, 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 let it sit, nothing's going to settle. That's not a suspension. That's a solution. And I don't know if they put that separately on here. I don't think they did. Colloids are different. Okay, solutions, did you need me to go back? I'm sorry. Okay, so even though it's not on here, solutions you cannot tell apart. Not Kool-Aid when you have the layer of sugar on the bottom. Okay, but the way you're supposed to make it, without ice in it, it looks the same. That's a solution. A suspension would be, I don't know. Pond water one works great. We have others here, but I don't like using all the ones that are up there. If you've ever put oil and water together, you put food coloring in the water, shake it up, oil still goes to the top, that would be a suspension. I used to have my IPC kids make, make a density columns. I haven't done that in a long time. Colloids. Colloids are different. Colloids exhibit certain things that the other two do not. The one specifically is called the Tyndall effect, which is not on here. We'll get to that in just a second. It is on the borderline between being homogeneous, which means it all looks the same, or heterogeneous, which means you can tell apart different areas. I don't care if you say homogeneous or heterogeneous. It's just not the way I was taught. In a colloid, it's like they're not really small like a solution, and they're not really huge like a suspension. They're just sort of like halfway in between, and it makes it hard to tell. Jello is an example of a colloid. If you shine a beam of light through Jello, you can see it's like through fog. You can see it go all the way through the Jello, but if you do that with just colored water, it won't do it. We're gonna fill this out. This is gonna take a minute. You need to be able to tell them apart. I don't know if this made it onto your CDA or not. Like I said, I don't see them. I know it's in the assignment that goes along with this. I should probably take official attendance too. That would be wise. So a solution has the smallest particle. So anywhere from 0.1 to 1 nanometer. That's unbelievably teeny tiny. They show something called the Tyndall effect, solutions do not show the Tyndall effect. The colloids are the ones that do. I'll show you what that, I forgot I went straight down. The particles do not settle. They're completely dispersed in whatever the liquid, well, it doesn't have to be a liquid, whatever the solvent was. You cannot separate them with like a coffee filter. It won't work. And it's considered to be homogeneous or homogeneous. I do not care how you pronounce that word. This person's not here. Bailey's not here. Nancy, Veronica, Declan. Who else is not here? Let's see. Lucas, Tiffany. I need to check online again too. Sebastian. Cleveland's not here. Julia. So Reagan. Where did everybody go? Braden's not here. Okay, sorry. All right, so now going with the next one, the colloids, they're medium sized, they're halfway in between. They do exhibit the Tyndall effect. It's the only one that's going to. This is why, I don't know how many of you drive. When it's foggy, do you turn on your high beams? Why not? Yeah, it's going to be, you're seeing the Tyndall effect. You're actually inside the Tyndall effect. It basically makes everything glow around you and you can't see. All right, the effective gravity for a colloid, they also do not settle. They're very strange. They're between, they still can't be separated with a filter, but they're halfway in between being homogeneous and heterogeneous. Like I said, they're sort of like right on the borderline between the two. So they have more characteristics of solutions. The specific way that you tell them apart, and this would be something that they would probably put on a regular test, this is how you tell apart a colloid and a solution. Because to the naked eye, they look like the same thing. One will show this tractor beam of light through it, the other one won't. Suspensions are going to be your largest particles from 100 nanometers and larger. No Tyndall effect. They do settle. You can use a filter, and they're heterogeneous. I need to double check online here real quick while you guys, because that's a lot. So I only had one person online. Let's see here. All right, nobody else. Oh my gosh. I don't know what's pollinating right now, but it's not nice. Ugh. Anybody still need Are we using specific vocab or wording for this table? No. Hold on. She's actually asking about this. Sorry. I'm responding to a teacher. Sorry, we work very, very well as a chemistry team, and if they have questions, I normally make sure it's taken care of. Just so happened to be we were on the exact same slide she was asking about. All right, now this Tyndall effect. You can do this at home if you've got regular Jell-O. So before you eat it, you get it out of a little container. Now it has to be like, it can't be like chocolate or vanilla, that won't work. And then you take like a flashlight, like one of the little flashlights, like a pen light, and you shine it through it. You're gonna see a beam of light wherever that crosses through the Jell-O. Okay, this is called the Tyndall effect. If you did this with the Jell-O before it gelatinized, like if you've never made Jell-O, it's like a liquid state and then it cools and it hardens. If it's in the liquid state, it's not gonna show that. It's only when it's in the solid state that the bone marrow from the animal bones that they used to make Jell-O starts to congeal, which by the way, that's what's in Jell-O. If I just ruined it, I'm sorry. But that's what makes the light shine through. You guys have this filled in, so I'm not really gonna like go over everyone, but you have your solution if it's a solid all the way down to a gas, just to get, because I'm pretty sure there's questions on your assignment that asks, and this is where you get the information from. If it's a solution, what would that be? If it's a colloid, what would that be? So for each particular type, I am not about to read this whole dang thing to you. On your assignment, it's number 8 on the back that this is supposed to help you with, but I'm not about to go through the entire thing with you. Gels and sols. You're almost done.
This is gonna be a fun one.
Y'all, shh. A gel or a sol is a colloid. An emulsion's also a colloid. Aerosols, like what you think of as the bad hairspray with the like ozone layer crap, those are colloids. All of these are colloids, and foam is also considered a colloid. You should have all of those. What you have left to do is we need to fill this thing out. Gosh, I hate having to yell over that thing. All right, so matter has 2 major categories. If it can be physically separated, yes, then it's a mixture. Okay, we're going to do the mixture first. So you've got homogeneous and heterogeneous, or homogeneous and heterogeneous, the way that I say it. These are things that can be physically separated. Now, on the other side, if they can't be physically separated, then that's a pure substance. Oh, okay. I went out of turn. I was supposed to finish that. I'll get to that second. Homogeneous is the same. Hetero means different. If it looks like the same, but it can only be told apart with the Tyndall effect, it's a colloid. They have medium particles. Suspensions can use filters. They have the largest. And then of a pure substance, this is going way back. The blocks on the periodic table are elements. They go together to make a compound. So that is the end of what you have on here. They're open right here. They have not been locked. Do not do things to make them be locked. Okay, let me double check. Let me stop this. I know, let me stop the recording. Some of you were still trying to